Okay, students, let's start with a new topic called projectile motion. First of all, what is projectile motion? Actually, projectile motion is a kind of extension of rectilinear motion. What we have studied in rectilinear motion is we have seen the motion in a straight line. Rectilinear motion means it's simple, it's a straight line motion. And under it, we have seen that the motion under gravity. Yes or no? Okay. But in projectile motion, it is not a rectilinear, so it is a 2D motion also. We can say it is a 2D motion. Let's take an example of real life example, like while we are studying this projectile motion. Real life example is like if you kick a football easily, if we kick a football, this is a football, we kick a, we always kick football in an angle and it's kind of like going this way, okay, this way. Or let's say we throw a ball at an angle. Not I am not saying it's straight line, at an angle. It will go like this way, okay. So, how we can differentiate projectile with rectilinear? First of all, rectilinear motion is 1D motion. It is a basic difference. It's 1D motion and projectile is a 2D motion. Okay. So let's start with projectile. And in projectile, what we are going to study is there are some many topics. I think it's two and three. Okay. So first is ground to ground projectile. Okay. Second is projectile from tower. In this, we have three cases: first, second, and third. Third and final is inclined projectile. Okay. So first we study the ground to ground projectile. After that, projectile from tower, and after that, inclined projectile. Okay. Okay. So let's start with it. Before going to projectile, I want to write a note, and this note is like sole concept of projectile. Before going to study projectile, this is the sole concept. And what is this? It is a Galileo's statement. Okay. It is a Galileo's statement. What Galileo has said is motion in mutually perpendicular direction doesn't affect, or we can say that mutually perpendicular direction is independent of each other. Okay, so why sir we can we say this is a sole concept? Because first of all, projectile is a 2D motion. Okay, let's say we make x-axis this way and y-axis this way. This is 2D motion. Okay. Now we are not throwing any ball and soccer ball in y-axis or alone in x-axis. Okay. We are throwing it at any angle. Let's say this is a theta at angle theta. Okay. And this will go like this. Okay. So in this projectile motion, we also can say it is a planar motion. Okay. So in this, velocity component is in x direction also and in y direction also. Okay. So that's why it is a Galileo statement is important, and it is a such kind of important that if you know this statement and you sometimes forgot the formulas, then you can able to solve any of the question. But I am expecting that you know the three basic equations of motions. Then you can easily solve the projectile. Whole chapter is based on this concept only. Okay. So now I start with the projectile. We have understood some of the basics of projectile. Now we will derive some formulas and all the things. Okay. And there is one beautiful thing also in projectile is that we can correlate this with rectilinear motion in a way. I am drawing the diagram here, but I will connect it later. Okay. We are throwing a ball with initial velocity u. It will go like this. Why? Because there is an acceleration g in downward direction. Okay. So what this acceleration will do is it will decrease the velocity as the particle goes up slowly, slowly. It will slow down, slow down, slow down, and at reaching the highest point, its velocity will become zero. But acceleration direction is not changing; it's downward. Okay. So it is now increasing the speed. It will come like this. Okay. And speed increases. And as we see in rectilinear motion, we have a symmetry of velocities. Okay, let's say if this point is A, this point is B, this point is C, let's say this is D, this is E. If we throw a ball with u velocity, when it reaches at B, let's say this velocity is V dash. Okay, and at C, it's of course zero, velocity is zero. But when it is returning its path, this velocity, this is also V dash. Okay, speed is same, but only direction is changing. So this is a symmetry. It's symmetry, it's a kind of symmetry. And when it reaches the point E, it's same velocity. It's same velocity u. Okay. So this is a symmetry in velocity. So in that way we have seen that the time taken of, we can say, time of ascent to reach the ball from initial position to C position. Okay. It will, what is the time? U by G. Yes or no? And we also see that time of descent is also u by g. Okay, so this is a symmetry. Yes or no? Okay. And I am also writing the maximum height. What maximum height this ball will achieve is, it is like u square by 2g. Yes or no? This is. Now I will connect these formulas in projectile motion also. Now I am starting the topic ground to ground projectile. Okay. Let's say this is ground and we have projected any object at angle theta with the ground, with the horizon, and it will go like this way. Okay. So remember the first statement. What we have, what Galileo has said is motion in two perpendicular directions are independent of each other. Okay. So first of all, we have to split. Let's say I am saying this is the velocity u. What we have shown. Okay. First of all, you have to understand the something like this is r. I am saying this point at A, this point is B, this point is C. And we have projected the ball at t equals to 0, and when it is at C, the time, let's say it's capital D. Okay. The maximum height this projectile is achieving, it is h maximum. Okay. So some basic terms. What is this? This is u. It is speed of object. This is, what is r? This r is, this is the range. When we throw at any object, it will cover how much distance in x-axis. This is the range. This is the range of projectile. Okay. And h is maximum height achieved by projectile. Yes or no? And one more thing. What is theta? Theta is the angle between u and horizontal. Okay. The initial velocity making an angle, some angle with horizontal, it is the theta. Yes or no? Okay. Okay. So in this ground to ground projectile, what we have to do is we have to find out the range, maximum height, and one thing also, time. T is the time period. Time of flight. Time of flight means how much time this object is in the air. Okay, this is the time of flight. Okay. So first of all, I am drawing a new diagram. Okay. This is the nomenclature kind of things we have seen. What we call R, H, theta, and T. Okay. Now I am making the new diagram, period diagram. This is ground. We throw at velocity u, it is angle theta, and it will go like this. Okay. Now, first of all, we have to make the component of this velocity. Okay. This is in x-axis, and I am considering this direction as x-axis, and this direction as positive y-axis. Okay. We make this component in x-axis. What is this? U cos theta. Okay. In y-axis, it is u sin theta. Yes or no? So now this u doesn't exist. It is divided into u cos theta and u sin theta, and we can clearly see this u cos theta and u sin theta both are mutually perpendicular directions, and according to Galileo's statement, they do not affect any of them. What does it mean by affect? It means that if there is any acceleration in x direction, it doesn't affect the velocity in y direction. Okay. Similarly, if there is acceleration in y direction, it doesn't affect velocity in x direction. Or what you can say, if there is velocity in x direction, it doesn't affect velocity in y direction. Okay. So we can say that we have to understand the motion in one direction also. Okay. We have to understand motion in one direction also, and separately we can merge this in last of the concept. Okay. Okay. So now here I'm going to find out these things, and what these things are: time period, height, range. Okay. So first of all, I want to ask you all that in which direction acceleration is there in the whole projectile. Which direction? I can say easily the acceleration is only in one direction. This is g. Okay. So there is gravity in y-axis, but is there any acceleration in x-axis? No, I don't think so. There is no acceleration in x-axis. So first of all, if we study the motion in x-axis, we doesn't apply the equation, three basic equation of motion. Okay, we simply put the formula of distance equals to speed into time, because this velocity is going to remain same in the whole motion. If you can point out any of the point, this velocity remains same. Sir, why is this? Because there is no acceleration in x-axis. Yes or no? And there is maybe some students get a thought like, sir, if there is any air resistance there, so I am mentioning it. Air resistance 0. Okay, I am not considering any resistance with air. Okay, so now there is no acceleration in x-axis. Yes or no? Only acceleration in y-axis. Okay, so this motion in y direction, we can easily say this is a kind of motion under gravity. Yes or no? This is a kind of motion under gravity. But what this velocity do? This velocity only drag the motion in right direction, in the horizontal direction, and this motion is a pure motion under gravity. Okay. Okay. I'm going to find out the time. Okay, so let's find out the time t. Before that, before going to find out t, I want to explain one more thing. What is this? This is the how velocity varies. How velocity varies in projectile. Okay, this is point A. Let's say this is B, this is C, this is D, this is E. At point B, let's say there is velocity v1. At C, let's say velocity v2. At D, let's say velocity v3. Okay. Now, let's say this is velocity making an angle alpha, any angle alpha, and let's say this is making an any angle beta. Okay, with the horizon. So we can make the component v1 cos alpha, v1 sin alpha. Here we have to make any component. No, it's a velocity horizontal direction. Now we are going to make the velocity component in v3. v3 cos beta, v3 sin beta. Yes or no? So symmetry is this. The velocity in x-axis u cos theta. I told you the u cos theta remains same in the whole journey. So sir, what about me? Okay, this velocity in x direction. So I can easily say u cos theta, or I am saying it is ux. Ux equals to u cos theta is equals to v1 cos alpha. Okay, and this is equals to v3 cos beta. Because velocity is in x-axis, there is no change in velocity because there is no acceleration, so we can write it like this. So sir, you are saying that velocity is only changing in y direction. Correct. I am saying this. Velocity is only changing in y-axis, in y direction. Okay. But there is also one symmetry. If I take velocity here like this, and at the symmetrical point, this point, I take velocity here. Okay. Then the vertical component of velocity, these both components are same. Like we have studied in rectilinear motion, na? At any point, symmetrical points, same velocity but direction is opposite. Yes or no? So this is the basic way to explain this. Okay, how can velocity vary in projectile? Okay, and you have to remember this. And let's talk one more thing. At point C, what is the velocity? You can easily say at velocity at point C is u cos theta, because it is the highest point. Here velocity in y-axis, we can say velocity in y-axis is 0 and the remaining velocity must be equal to u cos theta because it's in x-axis direction. Okay, it is not making at an angle theta or alpha, anything. Okay. And now we are equipped with all the basic concepts of projectile. Now we can use the equations of motion and we can find out the T, H and R. Okay. And I am making a clear diagram once again. Okay. This is U, this is theta, this is H. Let's say we have started at T equals to 0. This is point A, B and C. Okay, this is T equals to capital T. Yes or no? And this is A to C. It is range R. So we are talking about time. Okay, and I want to tell you one more thing. If we want to find the time and height, always see motion in y-axis. Okay, if we want to find the time and height, always see motion in y-axis. Otherwise, the remaining is range. If we want to find out the range, you can see motion in x-axis. Only at finding the range. Okay. So how can we calculate t? Now consider motion from A to B. Let's say I am talking about A to B. I am talking about A to B. Okay. This is u cos theta. This is u sin theta. Okay. This is u cos theta and velocity in y direction 0. I am talking about A to B, and I am applying equation of motion in y axis. Equation of motion in y axis. Okay. So what equation you think we have to apply so we can find out the time from A to B? I am not saying I am finding the time from A to C. I am saying I am going to find the time from A to B. Okay. So I think we can apply V equals to U plus AT. Why? Because I know the final velocity in y direction, initial velocity u sin theta in this direction, acceleration g in this direction. Okay. Okay. And now I am writing this y, v by u by a by. Okay. Why? Because I am applying equation of motion in y direction. So final velocity in y axis is 0. Yes. And one more thing, I am taking the upper direction as positive and lower direction in negative y axis is negative. Okay. V by 0, u by, this is u sin theta. Okay. This is u sin theta. A by, what is acceleration in y direction? It is g. So we can say it is minus g. Minus, why we took this as g as minus? Because it is in negative y axis. Yes or no? And t, let's say this is time. So what comes out is t equals to u sin theta by g. Yes or no? Yes or no? What is u sin theta? U sin theta, we can say it is initial velocity in y direction. So I can say this is u by g. Yes or no? And this time is known as time of ascent. Okay, and we can denote it by TA. Similarly, I can also find the time from B to C. Okay, by using the same equation, and we know here the y component velocity it's the same as u sin theta, but direction is changing. U by 0, I can find out, but answer comes out will be the same. T is equals to u by g. So I am saying this is time of ascent, this is time of ascent, and this is time of descent, and I am denoting by TD. And if we want to calculate time from A to C, then we have to add both. Yes or no? So what is T? T is time of ascent plus time of descent. Time of ascent is u sin theta by g, and time of descent is also same u sin theta by g. So total time comes out to be 2u sin theta by g. Yes or no? Or we can say it is 2u by g. This is time of flight. Okay, understood. And see, to find the time, we are applying the equation of motion in y-axis, and we are not seeing the motion in x-axis. We are totally ignoring it. Yes or no? And it's not wrong about it. This is the method to find out the time. Okay. Now find out the height. Okay. Now we want to find out the height, maximum height achieved. And I told you to find out the h, we also apply the motion in equation of motion in y direction. Okay. So what equation do you think we have to apply in y axis? I think if we can apply v square is equal to u square plus 2as. How do you know? How we can apply this equation? Because we know the velocity, component of velocity in y direction. Yes, we know this. We also know the initial component. We know the acceleration. Now the remaining part is s, displacement. We can find out in v. And one more thing, here we apply y because we are talking about y axis. Okay. So v by it's 0 because final velocity in y direction is 0. Yes or no? U by it is u sin theta whole square plus 2 acceleration it is minus g, it is in downward direction, it is minus g s. So it comes out to be 2gs u square sin square theta, and s comes out to be u square sin square theta by 2g, and we can say it is u by square by 2g. Okay, we can say this is u sin theta, we can say it is a u by, yes or no? So the formula comes out to be uy square by 2g. This is the formula of height. We can easily do this. And don't think that we have to only remember the formulas of P, H. You can remember it, we have to remember it, but you have to understand this also. Because when we are going to solve some good questions, we also know the how to apply the equation of motion in y-axis. So this is very important part. You have to understand this clearly. Okay? That's all. Okay, noted. Now, the remaining is range. Okay. It is easy. Why? Because we want to find out the range. And I have told you, if you want to find out the range, we have to see the motion in x-axis only. And in x-axis, initial velocity is u cos theta, and it will not going to change for the whole projectile. It will remain same because there is no acceleration. So if there is no acceleration in this axis of x, or we can say minus x-axis, it will not increase the speed definitely, or not going to increase the speed. Okay. So we can say from A to B, not A to B. We are saying from A to C. Okay, from A to C, we can say that easily. Distance is equals to speed into time. Yes or no? Distance. This distance is r. We denote it by r, range. Okay. Speed will remain same. X-axis, speed in x-axis, u cos theta. Time. And what is the time? We have calculated the time. From A to C we have calculated and we have put it there. Okay. It is 2u sin theta by g. Yes or no? Yes. So we can say it is 2u sin theta, u cos theta by g. This is 2uy ux by g. So this is the formula of range. Yes or no? Or we can say from here it is u square 2 sin theta cos theta. We can say it is sin 2 theta. Yes or no? It is a property by g. So remember any one of the formula. Yes or no? Okay. Understood? Any doubt till now? Any doubt? No? Okay. So we can correlate this. Now I am making the diagram here. What I have told you initially, when we throw a ball at u, it will go like this and come like this. And we can compare the velocity. This is, let's say, v dash, similar velocity in downward direction with v dash. We have also seen here, if this is v dash in symmetry, only direction is changing, velocity will be same. Yes or no? Same symmetry. And if you see the motion in y-axis, similar like this, only change is this, it is u sin theta. Yes or no? Now relate the formulas. Here we have find out the maximum height u square by 2g. Yes or no? We have find out the height u square by 2g. And in projectile motion, what we have seen is x equals to uy square by 2g. Yes or no? So what is the difference? This is u, this is u sin theta. Yes or no? Similar formulas. Time, we have seen here, time is 2u by g. Total time of flight is 2u by g. And in projectile, what we have seen? 2u by g. Yes or no? Velocity in y-axis. Similar formula. Okay. Okay. So if we understood this rectilinear motion with gravity, we can easily correlate this with projectile. Yes or no? If any doubt, please ask me. Okay. Now what we see? There is one interesting thing is range. What is the formula of range? It is u square sin 2 theta by g. Yes or no? And I want to find out the maximum range. Let's say I am going to find out the maximum range. If we want to find out the range maximum, this g is constant, u, we have thrown object with some velocity, this u remains constant. Okay. So this sin 2 theta will vary. Yes or no? If we want to find out the maximum range, then we have to maximize this sin 2 theta. Yes or no? So sin to theta to maximize this, you can make graph. We can see graph of sin theta is like this, and maximum value of sin theta or sin 2 theta, it comes out to be 1. Yes or no? So if this sin 2 theta maximum value is 1, then R max comes out to be u square by g. Yes or no? If maximum range is u square by g, then at what angle? There is some angle because we have done sin 2 theta equals to 1. We have put the value of sin 2 theta equals to 1. Okay. So sin 2 theta equals to 1. It means sin 2 theta equals to sin 90. Yes or no? 2 theta equals to 90. So theta equals to 45. Yes. So at this angle, at angle 45 angle, range will become maximum. Okay. Okay. Any doubt? Doubt? No. Okay. Now, let's take an interesting question. Okay. Let's do it. It's easy question, but you have to remember the things easily. So I am going to take question. Question is, if velocity of projectile at any time t makes an angle 37 degree with horizontal. Okay. Then find the velocity at this time. Yes or no? And I am making a diagram. Okay. Let's say we have thrown object at initial speed 100 meters per second. Okay. This will go like this, and let's say this angle is 53. Okay. And I am talking about at any time. Let's say at time t, it is here. This is t equals to 0, and it is making angle 37 with the horizontal. Okay. And this velocity is given 100 meter per second. Yes or no? So what question asks is, we want to find out the velocity at this point. At point B, let's say this is A, B, highest point C, it's D. We want to find out the velocity at point B. Okay. How can we do this? And add one more thing. Find time t also. Okay. So we have to find t and velocity at t. Okay. So here we can't use the formulas of t, h, r because we are not going to get anything. Okay. So that's why I have told you, when we derive the equations of t, h, and r, we have to see how we apply equations of motion in y-axis. Okay. Now this will be useful in this question. Let's see how. First of all, find the velocity at v. Let's say I am saying it is v dash. Okay. So make the component. This is v dash cos 37. Vertical is v dash sin 37. Yes. And making the component of a cos 53. This is 100 sin 53. Yes or no? I have told you velocity in x-axis will not change through the whole projectile because there is no acceleration. Gravity is only in minus y-axis. So this 100 cos 53 will be equal to v dash cos 37. Yes or no? V dash cos 37 is equals to 100 cos 53. We can easily find out 100 cos 53 upon cos 37. Yes or no? And put the value of cos 53, cos 37. I have told you many times to find the triangle is like this: 37, 3, 4, 5. Cos 53. This is 53. So cos 53 will be 3 by 5. Yes or no? Cos 53 based upon perpendicular. Cos 53. See the triangle in this way. Cos 53 will be 3 by 5. So put this value here. 3 by 5. Cos 37, it will be 4 by 5. So answer comes out to be 100 into 3 by 5, 5 by 4, 5, 2 times 50, 2 25. Velocity comes out to be 75 meter per second. Okay. This is the magnitude of velocity. If we want to find out the direction, we can easily say at making angle 37. Okay. This will give the direction. And another thing is we want to find out the time taken. Okay. See, if we apply equation of motion from A to B in y-axis, we know the initial velocity in y-axis. This is we know the final velocity. Yes or no? We know the acceleration. Only remaining in this time, so we can easily use v equals to u plus at. Okay. v by u by a by v is v dash sin 53 sin 37 sorry. U by is 100 sin 53, and I am taking this positive because this is in positive y-axis. So let's say this is plus, this is minus. That's all. Acceleration by direction, it is minus v, minus 10 into time t. Okay, v dash is 75. So we can see it is 75 sin 37 is equals to 100 sin 53. From here sin 53 4 by 5. Put the value 4 by 5 minus 10 into t. Sin 37 3 by 5. 75 into 3 by 5 is equals to, it is 80 minus 10t. Yes or no? This is 15 into 3, it is 45 equals to 80 minus 10t. 10t is equals to 80 minus 45 and t will be 35 upon 10. So time comes out to be 3.5 seconds. Yes or no? Clear? Clear or no? If any doubt, please ask me. No? Okay, so we will end this session. Okay? Revise this topic properly.